Hello everyone. Well, if everything went well, today would be Tuesday, May 7th, and doggone if we ain't almost there. Alright, so we are still talking about linear, quadratic, and exponential, how to tell the difference in both, and how to model these. Now we did tables yesterday. Now we're going to go to some application problems, which is kind of like real life situations and see what we can do. So we're just going to kind of go through this a little bit, and then you're going to have some ones to do on your own. Okay, the graph shows the flight of a marble tossed from 10 feet in the air. Well, it should not be a surprise to you after being in your classes, your regular math classes, that when we toss things into the air, that is a quadratic model. And in a quadratic model that's in the real world, typically it's this first quadrant that counts. So in other words, the marble was tossed here and then it fell and hit the ground right here. Okay? So would this be linear, quadratic, or exponential? And the answer is quadratic. Okay? Then it says which equation would be the best fit. Well, y'all, if we know it's quadratic, we can cross this out because that's linear. We can cross this out because that is exponential. Okay, so now we're down to 2. Now notice, this right here is going to open upward because your leading coefficient is positive. Here the leading coefficient is negative, so your parabola is going to open down. So just that alone, folks, tells you that D is the correct equation. Another way of knowing is this is your C, and your C is your y-intercept. And notice in the graph, my y-intercept is 10. So D is the correct answer there. Then it says, how many seconds will it take for the marble to hit the ground? Okay, so there's a couple of ways to do this. Okay, so first thing is we can look right here. Okay, and we can estimate it. That's not a problem, just estimate it somewhere below a 1. Okay, the next thing we can do here is we can pop this in our calculator and we can find where it equals 0. Another option is to attempt to factor this, but I'm going to let you in a little secret. It's not going to factor, and the reason why I know this is because when things factor, you get nice numbers for your answers, and this is not a nice number. This is an approximate. Okay, so we're going to estimate this. So it's a little under 1. I'm just going to say 0.75 seconds, which is 3/4 of a second. All right. Okay, let's go to our next one. Okay, let's read what this problem is about. The table shows the amount of money in Stefan's savings account over 10 months. Use the table to answer the questions. Well, the scenario right now doesn't really tell me what type of model this is, like the one before. So let me just take a look at the table. Okay, these are your X's and these are your Y's. And let's just take a look at these Y's. Well, there appears to be a pattern that's going on here. What is the pattern? Well, we're multiplying by 2. So we know that when we're multiplying, that is an exponential model. And 2 is my factor. Okay. So now it says which function would be the best fit for this. Well, let's take a look. Wouldn't be this one, because that's a linear model. Wouldn't be this one, because that's a quadratic model. Wouldn't be this one, because that's a linear model. So this one's real simple because this is the only one left. And if you notice, the form of this is y equals ab raised to the x power, and the b is your factor, which is 2. So notice they put a 2 here. And if you want to go one step further, this would be your y-intercept, and notice the y-intercept here would be a 1 because there's nothing there. Okay, so C is the correct answer. Okay. Write a sentence to describe Stefan's money. Well, his money is doubling every month. And we know that doubles is another buzzword for exponential. Okay. All right. Still on the notes part of this. Right. Notice here there's no graph and there's no table. So we've got to understand the words here. So it says Lee charges $9 an hour to mow grass plus $12 maintenance fee. Okay, well, my rate here is $9 an hour. And that rate, the way it's written, $9 an hour, that is a constant rate or a constant slope. In other words, every hour that he mows, what are we doing? We are adding $9. We are adding $9 every hour. Adding. Well, which type of model do we have when we are adding? Well, that's a linear model. Okay. Also, just to go further with what you guys should already know too, that's my rate, and if I keep reading plus a $12 maintenance fee, that's my one-time fee. That's going to be my y-intercept. Initial amount, one-time fee. Okay, so now, which equation would best model the situation? Well, we know it's linear. So check it out. Y'all, that's exponential. So that cannot be the correct answer. B cannot be the correct answer because that's quadratic. D cannot be the correct answer because that's a quadratic. So we're left with A. And notice, right there's your y-intercept. It's your one-time only fee. And then right there is your slope, $9 per hour. So A is the correct one. Okay. Use the equation to estimate how much money Leon would make after 6 hours. So notice, y'all, they're giving us 6. Is that my X or is that my Y? It's my X. So what I'm going to do is plug it in right here. So Y equals 9 blank plus 12, and I'm going to plug in 6. All right, go right to your calculator here. It's times 6, by the way, and then we add 12 to it. We get $66. Okay. All right, one more for notes. Okay, notice now we've got something else funky. Okay, in our first example, we had a graph. In our second example, we had a table. In our third example, we had a word problem. And now we've got pictures and patterns. Okay, so the model represents how the population of a town grew over 4 years. Now, when I see this, I know that populations grow exponentially, but to be honest with you, there's still not enough information here to know. Each block represents 1,000 people. Use the model to answer the questions. So if one block is 1,000 people, then this would be 3,000 people. This would be 9,000 people. And this would be 27,000 people. Okay, you actually, if you missed that part, you could still figure out what model this is. Because even if you had 1, 3, 9, and 27, what is your pattern? Well, your pattern is multiplying by 3. And we know that when we're multiplying as a pattern, we know that is an exponential model. Also, just a little trivia for you, which hopefully you know, when we've got a sequence where we're multiplying, what is the name of that? Well, it's a geometric sequence. It's a geometric sequence, and we do need to know that a geometric sequence is exponential. Okay? So now it says, which equation models this? Well, y'all, if we know it's exponential, can't be number 1, because number 1 is linear. Can't be number 2, because number 2 is quadratic. We're down to these two guys. Well, let's look at what happened. Well, we're multiplying by 3 each time. So C is the correct answer. This would be dividing by 2 each time. All right. Use the equation to estimate how many people will live in the town at year 5. Okay, well that's an X, and we just pop it in right there. So Y equals 3 raised to the 5th power. By the way, folks, that is not 15. Okay, that is actually 3 multiplied times itself 5 times, or 3 caret key 5. 243 people. And by the way, I messed up. It's not 243. It is 243,000 people. Glad I caught that. It's 243,000 people. Okay. Write a sentence describing the population in the town over time. Well, the population triples every year. See that word triples? Another buzzword for exponential. All right. And so now notice, now you've got your practice problems. You got one with a graph, you got one with a table, you got one with words, and you've got one with patterns. Go for it. Have a great day.